Welcome to this video. I will be discussing related rates, problems involving ladder, specifically the sliding ladder. So, related rates in differential calculus, related rates problems involves finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. So the rate of change is usually with respect to time, and dy over dt is a symbol read as derivative of y with respect to time, and dx over dt is a symbol read as derivative of x with respect to time. So as an example, a ladder 10 feet long rests against a vertical wall. If the bottom of the ladder side slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So we are given dx with respect to time is equals to 1 feet per second, and the value of our x is 6 feet. Now we have to find the value of y. Let's find the value of dy with respect to time. So the first step that we have to do is to use the Pythagorean theorem, and that is x squared plus y squared is equals to z squared. Now why we got 100? Because we are given 10 feet long, right? A ladder 10 feet long, and 10 squared is equals to 100. Now we have to simplify. The value of our x is 6, right? So we got 6 squared plus y squared is equals to 100. Now y squared is equals to 100 minus 36, because we had used the multiplicative inverse. The positive 36 will become negative. So we have to square both sides, like the y squared is equals to y, and the square root of 64 is equals to 8. So our final answer, or the value of 8, the value of y is equals to 8. The next step that we have to do is to derive our Pythagorean theorem. So we could have the formula that we're gonna be using in finding how fast is the top of the ladder sliding down the wall. So we have x squared plus y squared equals to 100, and the derivative of x squared is 2x, right? So that is 2x dx with respect to time plus the derivative of y squared, that is 2y dy with respect to time, equals to 0. Why 0? Because any constant, in finding the derivative, any constant would be equal to 0. So we have to find the dy over dt. So we have to divide both sides by 2y. So we got negative 2x over 2y dx with respect to time. Since we could cancel out the constant number, the 2, so we get the final answer, that is dy with respect to time is equals to negative x over y dx with respect to time. And this is the formula we're gonna be using in finding how fast is the top of the ladder sliding down the wall. So this is the last step I will be presenting, and this is the solution already. Since we found out that the value of y is equals to 8 feet by using the Pythagorean theorem, so we have all we have to do is just to substitute the value of our x and the value of our y, that is negative 6 over 8 multiplied to 1, because x is equals to 1, and we have this is not divisible, so we can only just reduce the value of our fraction. That would become negative 3/4 feet per second. So remember that the answer should always be positive, but the negative sign indicates that it is sliding down. So the distance, our solution, it indicates the distance from the top of the ladder to the ground is decreasing at the rate of 3/4 per second. Feet per second. That is, the top of the ladder is sliding down the wall at the rate of 3/4 feet per second.